Hi there, and welcome to the Manipulating Resources module from the Building Your First API with ASP.NET Core course at Pluralsight. I'm Kevin, and I'll guide you through this module. After the previous module, we now know how to get resources from our API. In this module, we'll take it one step further. We'll look into resource manipulation. That means we'll learn about creating, updating, and deleting resources. All pretty common functionality for an API. And as we're now manipulating resources, that means we should also validate the input. Let's get started with the first demo, creating a resource. In this demo, we'll learn how to create a new point of interest for a city. We know from the previous module that we'll have to use post for that. So let's dive in. We've already touched upon the fact that what we send to the API and what we get back from the API isn't exactly the same as what is stored in the data store. The further along we get in the course, the more this will shine through, especially once we add Entity Framework Core to the mix. But at this moment, when creating a resource, it already starts to become obvious. We've got a point of interest DTO here, currently used by our in-memory data store and also returned when getting a city or a list of cities. That's not a full separation yet, but looking at the point of interest DTO class, it becomes clear to see why we shouldn't use this for our post. It has an ID. That ID, that's something the server, our API, is responsible for, or at least in the application we're building. So it's not something that can be chosen by the consumer of the API. With that in mind, that also means that this ID shouldn't be part of the DTO used for creation. So let's add a new class, point of interest for creation DTO without that ID. Now there are systems where the consumer is responsible for choosing the ID. So it is a valid use case. And if that's the case, it would lead to the point of interest DTO and the point of interest for creation DTO to contain the exact same fields. But even in those cases, I'd suggest to keep these separate. It leads to a model that's more in line with the API functionality, making change or refactoring afterwards easier. And when validation comes into play in the next demo, you might want validation on input, but that's not necessarily the same validation, if at all, that's needed for output. So use a separate DTO for creating, for updating, and for returning resources. On to our points of interest controller. We'll want to add a new action and decorate it with the HTTP post attribute. Let's name it create point of interest. The route template contains the city ID first, followed by points of interest. So we accept the city ID as a parameter. And then we need to be able to get the content of the request. This request body will contain the data for the point of interest, which we want to deserialize into a point of interest for creation DTO. That's what the from body attribute is for. There's a few things that can go wrong with post requests. Things we'll have to check for. A new possible status code comes into play here. The consumer might send a bad request in such a way that the request body cannot be deserialized into a point of interest for creation DTO. If that's the case, the point of interest parameter will be null. And that's a mistake the consumer makes. So we want to let the consumer know this by returning a bad request 400 status. Also, the consumer might send a request to a resource URI that doesn't exist, adding a point of interest to a non-existing city. So we check for that and we return not found if the city doesn't exist. Let me copy-paste that over from one of the methods we created earlier. If both check out, we can add the new point of interest. But we need to calculate the ID for the new point of interest. And our data store currently works on a point of interest DTO. Not on a point of interest for creation DTO, so we'll have to map that DTO to a point of interest DTO. We can calculate the ID by running through all points of interest across cities and getting the highest value. We add 1 and we use it when creating the point of interest we're going to add to our in-memory data store. For that, we also copy over the values of our input to our new object and we add it to the city's points of interest. Now, as you might notice, this is quite cumbersome. Mapping can easily lead to errors. And running through all cities and their points of interest just to get an ID, well, that isn't ideal either. Performance-wise on one hand, and on the other hand, this code doesn't take possible errors when multiple consumers try to get an ID at almost the same time into account. But just as with most things in this course, we start somewhere and we keep on improving on what we learned throughout the course. So later on, we'll be able to work with auto-generated IDs and we will switch out this manual mapping to another component. But for now, this will do. Lastly, we also need to return something. For post, the advised response is a 201 created response. Helper methods exist, and the one we want is the created@route helper method. This one allows us to return a response with a location header. And that location header will contain the URI where the newly created point of interest can be found. If we scroll up a bit, we see that this would have to refer to the route to our action to get a single point of interest for a city. We can give that a name so we can refer to it. Let's name it getPointOfInterest. And then let's scroll down again and pass this in the created@route method. We first pass in getPointOfInterest. The getPointOfInterest route template needs a city ID and the ID of our point of interest. So for that we pass in an anonymous type with those values. And we also pass in the newly created point of interest, which will end up in the response body. That should be it. Let's give this a try. What we want to do is create a post request to cityid/points of interest. So let's add a point of interest to the city with ID 3, Paris. There's a nice cemetery there named Père Lachaise, which is where Jim Morrison and Oscar Wilde are buried. Jim's grave is quite small, a bit run down even, but nice in its way, and Oscar actually has a big tomb full of lipstick of all the people who come there and kiss the tomb. So it's definitely worth a visit, and this means that each self-respecting city info API should contain this info. And that is what we pass in the request body. We pass it in as JSON, but we need to tell this to our API somehow, so it knows how to deserialize this. That's what the content type header is for. In our case, with a value of application JSON. Postman can detect the format of the body, and it will automatically add this content type header. And this brings us back to the previous module, where we talked about input and output formatters. This tells the framework that it should use the JSON input formatter to deserialize the request body. Let's send this. We get back a 201 created response with the newly created point of interest in the body. And if we look at the header collection, we see that there's now a location header, so the consumer knows how to interface module. Postman can detect the format of the body, and it will automatically add this content type header. And this brings us back to the previous module, where we talked about input and output formatters. This tells the framework that it should use the JSON input formatter to deserialize the request body. Let's send this. We get back a 201 created response with the newly created point of interest in the body. And if we look at the header collection, we see that there's now a location header, so the consumer knows how to access this new point of interest. Let's give that a try. And indeed, we see our newly added point of interest. We now know how to create a resource. But when creating resources, one of the things you'll probably want to do is validation of your input. And we haven't done that yet. So that's coming up next. In this demo, we'll learn how we can validate input by working with model state. Let's have a look. Let's start by sending a request with invalid input. We'll send a post request, but instead of providing input that can be serialized into a point of interest for creation DTO, we send an empty body. I've put a breakpoint in the code we ended up with in the last demo, so we can see what happens. We've hit the breakpoint. Let's have a look at that point of interest parameter. It's null, and that makes sense as an empty body cannot be deserialized into a point of interest for creation DTO. So it's null, and that's invalid input. We check for that, and we return a bad request. So far so good. If we now look in Postman, we see that we indeed get back a 400 bad request. But there's more than one type of invalid input. Let's try sending a request without a name, with a property that doesn't exist, invalid property, and with a very long description that I got from the pirate Ipsum generator. Point of interest isn't null anymore. So this passes through our null check without any problem. The invalid property is ignored. We can live with that. Name is null. Description is very long. And that's not really realistic. More likely than not, we'll run into an error later on, depending on whatever rules we might have on our data store. Not null columns or max length restrictions, for example. Those will typically result in an exception. But we don't want our API to just hit an exception and return a 500 internal server error. We want to check these rules on our model, our DTO classes. After all, it's a mistake made by the client, not by the server. So it shouldn't return a 500 internal server error, it should return a 400 bad request. Let's dive into code. We haven't got any rules yet. We could check for null values or string length manually. And then return a bad request. But that will become cumbersome quite fast. There's a better way, data annotations. Let's open our point of interest for creation DTO model class and apply one. Required is a good one to start with. They can be found in the system.componentModel.dataAnnotations namespace from the system.componentModel.annotations assembly. And let's have a look at that. Here we see a list of data annotations we can use. There's attributes to check for valid credit card numbers, email addresses, minimum and maximum length, and so on. So with these attributes, we can already get pretty far as validation is concerned. Let's add a maximum length for name and description. Let's say 50 for name and 200 for description. But this is just part of the story. We also need a way to check if these rules are adhered to. And this is where the model state comes into play. Back to our points of interest controller. We're in create point of interest. Model state is a dictionary. It contains both the state of the model and model binding validation. It represents a collection of name and value pairs that were submitted to our API, one for each property. And it also contains a collection of error messages for each value submitted. Whenever the request comes in, the rules we just applied to our model, the DTO, are checked. If one of them doesn't check out, the model states its valid property will be false. And this property will also be false if an invalid value for a property type is passed in. So it's a great value to check to see if we can continue with what's in our action. Let's do that. We do need to keep the null check as the model state will be valid if the body can't be deserialized to the expected type. Let's try this. I'm gonna delete my breakpoints, we don't need them anymore. So let's send that request we sent earlier again. And this time we do get back a 400 bad request. The rest of our action isn't executed. There's more we can do. Let's open the DTO again. These attributes allow us to specify an error message. Let's try that for the required attribute of the name field. To return these errors to the client, we pass in the model state when we return bad request. And let's try that again. And this time we see we get back our customized error message and also the default error message for max length. But what about more complex validation? Rules we can't check with the built-in data annotations. Well, we will have to write code for that ourselves. But we can add errors to our model state so they are returned when we return a bad request with model state included. Say we don't want the consumer to input the same description as was given as name, with well format to the client error message. Let's try that for the required attribute of the name field. For max length, we'll have to handle that, so we'll write that check ourselves. If description and name are the same, we add a model error. We have to give this a key. This can be a property name, but it doesn't have to be. This way of working comes from the fact that the same framework is now used for building APIs as well as client-facing web apps. For those, adding the correct property name results in validation errors being applied to fields in the view bound to that property, so they're nicely displayed in line. And let's try this by sending a post request with the same values for name and description. So, name and description are the same. We send it, and this time we get back a 400 baht request containing our validation error message. Now, to be honest, I am not always a big fan of the approach taken here. Annotations mix in rules with models, and that's not really good separation of concerns. And having to write validation rules in two different places, the model and the controller, for the same model doesn't feel right either. But this is the default approach as taken by the old ASP.NET for some years now, and also by ASP.NET Core. So I did want to cover it. However, if you're building more complex applications, it might be a good idea to check out something like Fluent Validation, which offers a fluent interface to build validation rules for your objects. From version 6.4 and onwards, .NET Core is supported. And that covers input validation. Let's continue with updating a resource. There's two ways of updating a resource: a full update and a partial update. In this demo, we'll cover full updates. For that, we use the put HTTP method. We're back in our points of interest controller. As we learned previously, it's a good idea to use different models for create, update and read, even if they, at this moment, contain the same properties. So let's start by adding a DTO for updating a point of interest. The same rules apply as for creating one, so we'll add those as well. A name field that's required with a max length of 50 and a description field that has a maximum length of 200. Then the action on our controller. Let's name it update point of interest. For full updates, we'll decorate it with the HTTP put attribute. The route template contains the city ID first, followed by points of interest, and then followed by the ID of the point of interest we want to update. So we also accept city ID and ID as parameters. And then we need to be able to get the content of the request, for which we'll use the from body attribute again. That's it for the signature. Then, just as in post, we check for null, we check for that additional validation rule, and we check if the model state is valid. So I'll quickly paste that in, and there we go, the exact same code as in our post method. And by the way, this kind of drives the point home that having to have all these rules repeated over and over again in the model or in the controller actions is something that can be improved upon. It's okay for the simpler cases, but for more complicated cases, Fluent Validation might be a good option. Next, we check if we can find both the city and the point of interest we want to update. And if any of those fail, we return not found. First, let's find the city, and if it's null, return not found. And then let's try and find the point of interest. And we also return not found if that point of interest can't be found for this city. And then we can update. And this is where this full update principle comes into play. According to the HTTP standard, put should fully update a resource. That means that the consumer of the API must provide values for all fields of the resource, save for the ID, as that one is already coming from the URI. If the consumer doesn't provide a value for a field, that field should be put to its default value, which conveniently it will have in the inputted object. We must thus always update all fields. In our case, that's just a name and a description. And lastly, we return a 204 no content. That means that the request completed successfully, but there's nothing to return. You can also return a 200 OK, containing the updated resource. But typically for updates, you'd return no content, as the consumer already has all the information. After all, it's the consumer who sent the content that had to be changed. Let's try this out. We'll send a request put to update New York City's Central Park name and description. We get back a 204 no content, so the update was successful. Now let's get this point of interest. And indeed, it's been updated. And now let's try out that full update principle by not providing a value for description. So that's a new put request with only a name in the body. We get back a 204 no content, so the update was successful. Now let's get that point of interest again. And the description was set to null. This is completely correct according to the HTTP standard, but it might not be ideal for consumers of the API. Imagine a case where a resource has 20 fields. You only want to update one of those fields. That would mean that the consumer would first have to get the full resource, including all fields and values, from the API, and then send them back with a put, but with one field changed. That's quite a lot of overhead. It would be nice if there was some sort of way to send a change set over the wire, only containing those fields that have to be updated. And there is JSON document combined with the patch method. Let's check that out. The patch HTTP method is for partial updates. But what should the body of a patch request look like? It needs to contain the fields that have to be patched and the value those fields need to get. And if you take it one step further, it also needs to contain an operation that has to happen. For example, a patch request that copies the value of one property to another property. Luckily, there's a standard format for this. The standard is named JSON Patch RFC 6902. And what it does is define a JSON document structure for expressing a sequence of operations to apply to a JSON document. In our case, that document to apply the sequence of operations to is the JSON we get back when requesting a resource. In essence, the consumer of the API will create a JSON patch document as the body of the patch request, adhering to this standard. Such a body is a list of operations, like an add, replace, copy, etc. operation, including the respective field names and values. Our API should accept such a patch document and then apply all those operations to the resource. Let's have a look at an example of such a request body. It starts with straight brackets, signifying an array. And that array is a list of operations that have to be applied to the resource. We see two operations on screen. The first one is a replace operation signified by op. Path signifies path to the property, name in this case, and value signifies the new value that should be given to the name property, new name. The second operation replaces the description with value, new description. Other operations are supported as well. In fact, there's a lot of cases that are supported by JSON Patch. You can add to an array, remove from an array, replace one value by another, copy or move a value, change nested properties, and so on. It's a really powerful standard. Going over all of these would definitely lead us too far. The most important thing to remember is that a JSON patch document is essentially a list of operations like add, remove, replace, etc. that have to be applied to the resource, allowing for partial updates. Let's check that out with a demo. In this demo, we'll look into how we can partially update a resource with patch. We're back in our points of interest controller where we left off. Patch is signified by the HTTP patch attribute. Each route template is the location of the point of interest, just as with a full update. We then need an action, let's name it partially update point of interest, that accepts these two parameters. And then we need the input from the request body as a third parameter. So we can again use from body, and then we need a class to which we can deserialize that list of operations. That's a JSON patch document from the Microsoft.ASP.NET Core.JSON patch namespace. Such a document works on a specific type. So what is that type that we want to patch? There's two ways we can go about this: point of interest TTO or point of interest for update TTO. A point of interest TTO, well, that has an ID. And you do not want to allow an update to change the ID of what you're updating. That would no longer match with the ID we pass in the URI. So if we go this way, we need yet another validation check. The other way is applying the patch document to the point of interest for update TTO. That already includes the validation annotations, and it doesn't have an ID. But it does mean we need an extra transformation. We need to get the matching point of interest and map it to a point of interest for update TTO before applying the patch. I personally prefer that approach, as it's much more in line with what we've done up until now. But if you don't like to work with different DTOs for different types of actions, just remember to check that the patch doc doesn't try to change the ID. First things first, we check if the input isn't null, and if it is, we return a bad request. Then we check if the city and point of interest can be found. If not, we return not found. This is getting quite familiar by now. And then it's time to apply the patch document. It's a patch document that works on a point of interest for update TTO. So we need to transform our point of interest we got from the store to a point of interest for update TTO. And to this variable, point of interest to patch, we can then apply the patch document. Applying a patch document can be done by calling apply to on the patch document, passing in the object to patch. But something might be wrong with the patch document. We could have created the patch document to change a property that doesn't even exist, for example. We want to know that, because if that's the case, the consumer has made a mistake and we need to return a bad request. Well, if we pass in the model state in the apply to method, any errors of that type will be added to the model state's error collection. So we do that, and afterwards we check this state and return bad request if it's not valid. If it is valid, the update was successful. So the rest of the code is exactly the same as for a regular update. We copy over the property values and we return no content. Let's give that a try. We're going to start simple with a patch request to change the name of New York City's Central Park. As we learned, a patch request's body contains a JSON patch document, an array of operations. To change the name, we pass in replace as the operation, name as the path, and a new value for the name. And we get back a 204 no content. That means the request was successful. Let's try and get New York City's Central Park. We see that the name has indeed been replaced. Let's try another one. A JSON patch document consists of an array of operations, so we can add another operation. That's replace as operation value, description as the path, and the new value for the description. We again get back a 204 no content. And if we get New York City Central Park, we see that both name and description have been updated. Now let's try sending an invalid request, an update for a property that doesn't exist. So we pass in invalid property as the path. And this time we get back a 400 bad request, including the validation error on the JSON patch document. Replace of a value means removing the value first and then replacing it with a new value. So the error we get first is that the property at the unexisting path could not be removed. So this is looking good. But we're missing something. What about our validation rules? Let's try a request that would lead to a validation issue. We're going to clear the name. This is a required field. we have a required annotation on the name property, so we do not want this to succeed. So we send a JSON patch document containing one operation, remove the name. And we get back a 204 no content, so it succeeds. And let's get this point of interest now. And it looks like the name has been cleared. That's not good at all. So why is this? Let's go back to our code. After having applied the patch document, we check if the model state is valid. And apparently it is valid. Otherwise, the rest of the code wouldn't be executed. This model state contains errors on the inputted model. And the inputted model, well, that isn't the point of interest for update TTO. The inputted model is a JSON patch document. So as long as that document is valid and the patch document can be applied, the model state will be valid. So what we need to do additionally is check if the point of interest for update DTO is still valid after applying the patch document. First, let's add that extra validation rule we couldn't achieve with validation annotations. Name and description must be different. Then let's validate. To do that, we can use the try validate model method, passing in the now patched point of interest for update DTO instance. This triggers validation of this model, and any errors will also end up in the model state. So after that, we check model state again and return bad request containing the errors if it's not valid anymore. Okay, let's try that again. Let's try and remove that name. This time we get back a 400 bad request and the expected error message. And let's try one more. If we try updating name and description to the same value, we should also get back a bad request. And that is indeed the case. So with that, we've learned about patching for partial updates. As we've seen before the demo, it can also be used to manipulate arrays, to copy or move values and so on. It also works on dynamic types, allowing you to actually manipulate your objects by adding or removing properties at runtime. So it's really powerful. There's one more HTTP method we have to look into: delete, for deleting resources. So let's have a look at that. In this demo, we'll learn how to delete a resource. And deleting resources tends to be one of the easier things to do. We start out on our points of interest controller and we add a new action. Let's name it delete point of interest. For delete, we decorate the action with the HTTP delete attribute. Just as for update, this has the route to the specific point of interest we want to delete as route template. So the parameter list consists of a city ID and an ID for the point of interest. Just as before, the first things we do in our action is check if the city and point of interest for that city exists. And if they don't, we return not found. If they do, we can effectively remove the point of interest. The response has no body, so that's a 204 no content. And that's it already. Let's check this out. Let's send the delete request to New York City's Central Park. We get back a 204 no content, so that checks out. Let's just make sure by trying to get all points of interest from New York City. And we see that indeed Central Park has been deleted. And with that, we've covered everything about manipulating resources. Let's have a look at the summary. We started this module by learning about post to create a resource. When the resource has successfully been created, a 201 status code response is what we should return. That was the first time we submitted a request body to our API. The format of it is designated by the content type header. When talking about input, it should be validated. And that's what we learned next. We can use data annotations on our DTO classes. And then we can check for these by using the model state. That's a dictionary containing both the state of the model and model binding validation. Whenever a request comes in, the annotations applied to the model, the DTO, are checked. If one of them doesn't check out, the model state's is valid property will be false. For those rules that can't be checked with data annotations, we can add a manual check and call add model error on the model state if necessary. And then we looked into updating a resource. Put is for full updates, patch is for partial updates. Partial updates are often preferred, but they require a way to send through a list of changes. That's where the JSON patch standard comes in. It's essentially a set of rules for expressing a sequence of operations to apply to the JSON resource we want to update. After a successful update, a 204 no content status code, or alternatively a 200 OK status code, should be sent back with a response. Delete is for deleting resources, and that warrants a 204 no content status code as a successful response. So what else does a good API need? Well, I'd say a certain amount of logging is definitely required. ASP.NET Core has a built-in logger service that we can use for that. But before we can use that, we must look into one of the most important ASP.NET Core concepts, working with dependency injection and services. That's coming up next.